guys, this is Mrs. Gastler, and in this video we're going to talk about the difference between mass and weight. And at the end of this lesson you should be able to explain the difference between mass and weight and convert between mass and weight. So let's get started. To begin with, we're going to go through these lessons or these statements here, and we're going to pick the right word. So which one is the measure of the amount of matter in an object and only depends on the number and kind of atoms that compose it? That would be mass. So we're going to go ahead and circle that one. I'm going to highlight it. The next one, which one is the measure of the amount of inertia an object has? That one, remember, that's the resistance to a change in the motion. That would be the mass. And which one is a measure of the gravitational force on an object? That would be the weight. So we'll select those words there. Which one depends on an object's location? That would be weight. Remember, your weight changes when you go to some new place, whereas mass does not. Mass doesn't matter where you are. In other words, a stone would have the same mass, whether it's on the surface of Earth or on the surface of the moon. However, its weight depends on its location. So we'll go ahead and circle those two words there. On the moon's surface, where gravity is only about 1/6 of Earth's gravity, the mass of the stone, let's see, that would be the same as on the Earth. Yep, that's it. The mass stays the same no matter where you are, unless you lose an arm or a leg, then your mass would be definitely different. Let's see. While mass and weight are not the same, they are directly proportional, because the more mass you have, the more weight you're going to have. So directly proportional, that means they change the same. Inversely proportional means they change in the opposite ways. We'll come and see some more of those kind of proportionalities a little bit later when we talk about Newton's second law. In the same location, twice the mass has twice the weight. Okay, the unit of mass we use kilogram, and the unit of weight we use Newton. Okay, so that's the difference between mass and weight there. In the next part, we're going to talk about converting between mass and weight. So to begin with, we're going to see the equation here. So that's what it looks like. So Fg, that's the force of gravity. You might remember that one from our last unit when we were talking about forces. Let's talk about what all those letters mean. So Fg stands for weight. We measure it in newtons, capital N for newtons. M stands for mass. We measure it in kilograms, kg for kilograms. And G, right now we're going to talk about G as the gravitational field strength, and we're going to use it as newtons per kilogram. Now, sometimes you're going to need to find something else like the mass, and that's what the formula looks like there. We just divided both sides by G, so the G is on the other side. And sometimes you need to find G, and that's what it looks like right there. Okay, now on Earth, G has a particular value because it's the gravitational field strength, right? And that is 9.8 newtons per kilogram. Sometimes we call G the acceleration due to gravity, so you might see it as acceleration due to gravity in some of the questions on the practice and in some of the questions on quizzes and tests and whatnot. Or you might hear it talked about that way in other places. But knowing G can tell you how strong gravity is in a place where it's being measured. Oh, I've got place in there twice. You can ignore that. Just there we go. Okay. It's measured and you can compare it. Okay. So if you look over here, I've got this chart. It's got a bunch of gravitational field strengths right behind my face there. There we go. And so you'll see there's some big numbers. The biggest number there looks like Jupiter. Jupiter must have the strongest gravity. Okay, so that would be the place where you could go and weigh the most. Where could you go and weigh the least? Ooh, Pluto. Pluto has the tiniest number there, 0.6. So if you wanted to weigh the least, Pluto is where you should go. Okay, so that's what you can do with knowing the gravitational field strength. So let's keep going here. So we've got some example questions. Okay, at the doctor's office, Taylor has a mass that is measured to be 67 kilograms. How much is Taylor's weight? So we're going to be finding Fg. That formula, remember, we just wrote it down there as M times G. So we're going to be plugging our numbers in. Let's see if I can touch it. There we go. 67 kilograms times that 9.8 newtons per kilogram. That's just plugging in the numbers that we have there. 67 is in the problem. 9.8 is that number that we just wrote down up here, 9.8. It's also in the chart over here. If I can highlight it for you, there it is in the chart. And there's the 67 kilograms right there that we just plugged in. Okay, now we're going to type that into our calculator, that little dot right there. When we write them next to each other, that means we're multiplying. When we multiply those in our calculator, I got 656.6 newtons. Okay. The next question, Taylor then travels to a planet, but he doesn't tell you which one. Okay, Taylor sends a readout from a scale that says his weight is 248 newtons. So his weight has gone down 248 newtons. So he's not at Jupiter or Saturn or Uranus. Those numbers are higher than the 9.8. So it's definitely not those. Okay. What planet did Shaler travel to? You see what I did there? I was able to compare. Okay, so in order to figure out what planet Taylor traveled to, I need to find out what that gravitational field strength is. So I'm looking for G here. G is going to tell me the answer to that question. So that formula looks like this. Fg over m, it's literally like right here, okay? So we just copied it down there. I'm going to be plugging my numbers in, so that 248 is going to go on top, and Taylor's mass was in the previous problem, so it's at 67. That goes on the bottom. In this case, it is a bigger number on top and a smaller number on bottom, but remember, it's just whatever the force is divided by whatever the mass is. Top divided by bottom is what you plug into the calculator, and I got 3.7 newtons per kilogram. When I look over here to find that in my chart, 3.7, there it is. Looks like Taylor is in Mars, okay? And so that's what it looks like. Make sure when you are doing these problems, you get 1 whole point for writing down the formula without putting any numbers in it. That is the most commonly missed point on the test, okay? And then typing in your numbers, writing down your numbers the way you type them in the calculator, okay, is another whole point that people often miss on the test, okay? And then the answer is usually what people get the points for, because you're able to write that one down. But you've got to do all 3 of those things, okay? Make sure you do all 3 of those things. So if you have any questions about any of this stuff, make sure that you ask for help from your teacher. Thanks for watching.